Hello, my name is Kuncheng. This is homework 11 problem 2 presentation for course stochastic and probability. Let's see this problem. This problem it provides three different functions, and the requirement is, does the three functions present an autocorrelation function of a WSS stochastic process by setting V equal to tau, or a spectral density function by setting V equal to omega, or both. So for this one, we can easy to write as a function equation, functional equation, like how to write that. So let's see. We need have R tau and S omega is the R tau is an autocorrelation function of the xt, and the SW is a power spectral of the xt, and also xt is a WSS stochastic process. And according to the definition for the note, so we know if R tau is the autocorrelation function, so it must have R tau is even, R tau less or equal than R0, and the Fourier transform of R tau is non-negative. This is for the autocorrelation. And also another requirement for the power spectrum is SW is non-negative. This is the only requirement for the spectrum, power spectrum. So let's see the three functions. The first one, if V equal to exponential negative absolute V. For this one, we can easy to know if negative V equal to exponential negative V absolute equal to E negative V equal to FV. So this one is even. It satisfies this condition, and also we can easy to know this one must less than exponential 0 square equal to 1. Must, we can easy to plug in any number for the V. So this one is right. And also we can find the Fourier transform, the exponential can be transformed this form by the Fourier transform table. So, and we can easy to see this one always is non-negative. So this one can represent autocorrelation R tau. And for another one is power spectrum. So we can easy to change V to the omega, also greater than 0, so it can represent is the power spectrum. For the second situation is Fv equal to sine square V divide V square. And also we can consider the three conditions, and we just change V to the negative V to the negative V, and we can know Fv equal to F negative V. So this one is even. And also if V if we change to tau and the tau goes to 0, and we can find limit easy to know the limit of the function equal to 1, and we can easy to know the sine square tau divide tau square less or equal to 1. So the second condition is satisfied by this function. And also we can know we can easy to see this function must have a Fourier transform to be like a function, like, because we have the function table, we know this one will be the function like this. So we easy to see the area of the function is greater than 0, so we know the Fourier transform is non-negative. So we can easy to know this one can represent autocorrelation on top. And for the power spectrum, it's easy. We just easy to change the V to the omega, and also easy to know this greater than 0 or equal than 0. So it can represent power spectrum. And for the last function is if v equal to 1 or 0. So that's like a high pass filter. So like here we have the absolute we have the condition like this. And for this one, we can easily know according to the Fourier transform table. So for this function, do the Fourier transform, it's equal to sine alpha omega divide omega. This one maybe this one is not non-negative function, because easy to see this one could be less than 0. So it cannot represent our tau. And for the power spectrum, we can easily to change V to the omega, and we know the omega must greater than 1 or 0. So it can represent power spectrum. So that's it. Thanks.